Hello. My name is Pavel Savyanko. Welcome to a new Cube video, and today I show you how to unclutter whole tree display in CubeGUI. Let's do it. Okay, we are back into our terminal, and today I would like to present you a little bit on another possibility to unclutter display of CubeGUI to have more comfortable browsing of the call tree. So we start our CubeGUI and we open an example, so like this file, for example, and I would like to show you two features. Uncluttering of display and automatic demangling. So if one has a measurement done with ScoreP, depending how one has configured ScoreP, whether it is using GCC plugin or another techniques, the ScoreP creates a call tree and creates entries in this call tree, called regions, with some names. These names are usually coming from these mentioned infrastructures, GCC plugin or others. And like in this example, so that is gm-esh, exclude params, and so on, add glib, al glib, get env, whatever it is. And so on. So we see that they are here in the very same form as we usually expect them from source code. If we take a look at the detailed info for these elements, and especially on this part, we see that the ScoreP actually stores two names. One is mainland form, which is used by the compiler and linker internally, and one is actually human readable form with namespace, class, parameter list, and so on and so on. So if ScoreP delivers this mangled and demangled form, then we are fine. We can work with this call tree. We see the region names as we expect them to be, how they are in our source code. So that is fine. Sometimes ScoreP doesn't demangle the region's name and creates a cube file with such a hardly readable region name. So I have here one example, like for example this one. So and one sees that in the call tree here, one has one huge name in its mangled form. Even if we take a look at info, we see that the ScoreP didn't manage to demangle it, and both versions have the same demangled form, mangled form, and is hardly readable. Of course, if one is familiar with the way how this name is constructed, one can probably decipher it. So multi-q, that is some namespace details, is probably also sub namespace, then the class, then the call, and so on and so on. So, but that is clearly absolutely not handleable. So the CubeGUI offers here help. If one has configured CubeGUI during the installation with support of demangling, it depends whether the libraries were available, then the config summary should report that the demangling of names is supported by CubeGUI. Would here stand no, then of course it wouldn't help. But if it is yes, it means the CubeGUI can offer you help in this situation. So for that, one goes into the menu display, trees, and one has to enable the menu item demangle function name. So if we enable it, we see immediately that this display has changed nothing has changed internally in the region description, but in our call tree display, we see now human readable form of the name. So this case is of course of little help because this template is here really nested, but it is better readable than the form what came from the ScoreP. So one can recognize here template queue with a mutex, task, then another sub template, P2M processor, solver, and so on and so on. So one can, out of this name, already get connection to the one source. In this way, one has a better job to browse the call tree and to analyze the performance. So another feature which I would like to introduce you is uncluttering of the call tree. So if one has such large names like this one would like to perhaps to shorten these names in order to have it a little bit more, to have a readable form. So this example is probably less suitable. Let's take a look at this example, original one. So there is also call tree, and if it will pop up. So that is an example of a typical C++ code, and the ScoreP created the call tree, and of course created all regions with the names, and these names are readable, but not that easy as one would like to, probably. So there is a one sees that this region is a call, is orient mesh, G face some class, it returns void, its operator with these parameters, and so on. It's of course very important information which is needed to distinguish one region from another, especially if one has overloading and overriding and templating. But for the browsing of call tree, that might be really cluttered. So there is a way to simplify this display a little bit. So we go into the display, we go into the tree, and we see here the menu item shorten function names. If we click it, we see that the CubeGUI allows you to hide argument list. It allows you to hide return value, especially if we are not interested in these parts of the name, and the function scope. So for example, if we take a look at our call tree current, so if we hide the argument list and click apply, so we see that the parameters are gone. They are maybe important for the call, of course, and for the structure of the program, but for the performance analysis, not really, because we can identify calls based on the unique name. So mesh 3D, mesh 2D, and 1D, they exist only in one class, only in one file. So why do we need to bother ourselves with display of parameters? The same is with return value, especially if return value is not relevant for to distinguish the call path, so we can hide it too. And we see that the names are getting shorter and shorter. And of course, by C++, you can have a one can have a relatively nested structure of names, namespaces, and then call class name, and then the call, and so on. So we offer also here relatively flexible selection of this nesting of display. Of displaying this name. So for example, I select that I would like to hide some function scope, and then I can define up to which scope do I hide. And here I select actually what I want to get shown still. So like for example, show up to 4 levels, so it means the calls, the class names and namespace, they stay. So if I click, nothing changed. But if I shorten it and go on level 3, for example, and 2, then here we see that the class names are the namespaces are gone, and if we are not interested also in class names, we can hide it as well. So, and then one obtains the call tree, which consists only of the names of the calls of the methods. Sometimes it is sufficient, sometimes it's not. Like for example, here is example operator, operator, two different call paths, but if we see that call tree, we might not understand why this operator and this operator are distinct call paths. So if we take a look, of course, then we will see that they belong to different classes. That is due the fact that we shorten too much. Yeah. So if we display one level, so class name, we see that it belongs to different classes. So that is hiding in C++ code. If we take a look in this dialog, we see that we can also unclutter a little bit the Fortran subroutines. So for that we take a look at our another example, Casino, for example. So that's the Fortran code. This we can see, for example, is here. We see that the source code is Fortran. Of course, Fortran has a different method of the mangling and demangling, and the Fortran's names are usually more readable than from C++, coming from C++. Nevertheless, it tends also to get more and more unreadable, especially if one has not trivial structure of modules and source code. So here we offer a possibility to hide the module names. Yeah, and in this way, that's like if you take a look here, the Slater dot WFN ratio Slater, then the module name disappears and only the call stays. So in this way, the CubeGUI unclutters the call tree view a little bit, not much, but still something. So I hope you like this feature, and it will simplify your performance analysis in the future and work with the CubeGUI. Give us a like, comment, and subscribe. And see you next time.